Hi everyone, my team and I will be giving a final year major project presentation and demonstration in this video. My team members are Bharat and Anand Darshan and I am Akansha Agarwal, and we have done this project under the guidance of Dr. Manoj Challa sir. So our project is securing medical data records using blockchain in a cloud computing environment. The current healthcare industry lacks securing of medical records, and this causes lack of trust on the patient's side. Currently, a centralized approach has been adopted, which is extremely vulnerable to breaches. Privacy is a fundamental human right, and to address this gap in the medical industry, we have developed a solution. The main aim of the project is to develop a distributed, decentralized medical data privacy and protection model using the latest technologies like cloud computing, blockchain, and advanced cryptographic algorithms. We have also created a fully responsive user interface website with which the patients, doctors, and insurance company agents can interact in a secure as well as a smooth manner. Hence, we intend upon creating a revolution in the healthcare industry with our proposed model and also want to change people's view regarding the importance of protection of medical data. This is a high level architectural flow of our model. We have three modules: doctor module, insurance companies, and then we have the patients module. They interact with our website, which has been created using HTML, CSS, Bootstrap, Material UI, and React in the front end side, and Node.js and Express.js towards the back end. Patients have their login credentials stored in MongoDB, through which authentication is achieved. Patients has complete control over their blockchain, and they are the ones who grant access either to the doctor or to the insurance agents based on the requirements. With the help of IPFS, which stands for Interplanetary File System, we enhance decentralization and provide an effective mechanism to store the blocks of the blockchain. We have deployed the entire model using the Heroku platform. Coming towards the development tools, for the front end, we made use of HTML5, CSS3, SCSS, JavaScript, handlebars, and React.js. In the backend, we've made use of Node.js and Express.js. We've made use of MongoDB as a NoSQL database. For storage of blocks of the blockchain, we are making use of IPFS, which also enhances the decentralization of the model. We are making use of Heroku platform for deployment of the entire model. And we have integrated technologies like blockchain, cloud computing, and cryptographic.
Model has three major actors or modules that are interacting with the blockchain medical data system. Each of them have a dedicated login system in common, and the credentials are stored in MongoDB for the purpose of authentication. The patient interface as a registration system, and the form data will be used to add the genesis blocks for the patients. Patients have the privilege to grant access to doctors so that doctors can provide new prescriptions and add to the patient's chain. And also patients can grant access to the insurance to claim the insurance amount. Doctor interface as a view of patients that have granted access to them. And after examining and the treatment process, the doctor can add the prescriptions and reports to the patient's blockchain. Insurance agents will analyze the medical expenses and then decide on whether the insurance amount should be granted or not. Next slide. These are the algorithms that are used in our systems. They are RSA, proxy encryption, and SHA-256. RSA is an asymmetric cryptographic algorithm which works on two key bases, where public key is used to encrypt the medical data to generate ciphertext, and private key is to decipher the ciphertext. Next, proxy re-encryption is used for secured data sharing. It is a crypto system which allows doctor or insurance agents to read the medical data of patients without having the access to patient's private key. In proxy re-encryption, a re-encrypted key generated with the patient's private key and doctor's public key is used to re-encrypt the ciphertext. And the re-encrypted key can be decrypted and viewed by the doctor through his public key. SHA-256, also known as Digest, is a content-based hashing algorithm which is used for digital signature for the block. It generates a 256-bit unique hash for the blockchain. by considering the parameters such as nodes, block data, and private previous hashes. Next. This this is the time sequence diagram of the data flow of and interaction between modules. We have three users, that is patients, doctor, and insurance agents. Initially, patients can enter credential and log into their modules, and then they can grant access to either doctors or insurance agents. Doctors can enter their credentials, and after examining the patients, they can provide prescriptions and information which will be encrypted using RSA, and the block gets created and then stored in the chain. Later, the ashes and the private keys will be with the patient. They can be entered into the patient module to in order to view their chain and then view their medical data.
As you can see, it is hosted on the 3000 port of our system. So we have initially named our website as Medilab Hospital. As you can see, we have just given a prescription or some guidelines about what technologies or what tools we are making use over here. So finally, we'll get started with our project. So as Bharat and Akanksha mentioned, we have three modules in our system. So one is patient module, doctor module, and insurance module. Let's go as per the time sequence diagram that Bharat had mentioned. So initially the patient login. So this patient login actually has an gets authenticated with the backend system, which is MongoDB as of now. So I will be entering my email address over here, and the password is something that I have created as of now. And once I gain access into the patient module system, as you can see, I could either get the block information through get block data button, or either I can grant access. So what right now I'll be doing is I'll be granting access to Dr. A, and either to provide a prescriptions or either to provide a general medical checkup to me. So once I'm granting the access, I could submit this grant access button, and there is a message indicating that access has been sent. So now if I would log into the doctor module, since I've initially given the access to Dr. A, I'll be typing out his credentials. And as you can see now, right now I have initially requested him for a general prescriptions or for a medical data checkup. So what the doctor module can do is he could either update or he could either view my blog. So viewing my blog other internally makes use of proxy encryption, where the patient is without the patient sharing his or her private key. So I would be trying to update, or I would be trying to create a new data block for the patient. So as you can see, there is some personal related informations about what the doctor is trying to examine, or what he is trying to or what kind of prescription is he trying to provide. So he will check for the conditions that the patient have. This is just a demonstration. This is just used for a demonstration purpose. In real time, we could have an X-ray to either to upload an X-ray image, or to either generate or tell either to generate or tell about what kind of fevers or what kind of diseases does the patient is suffering from. So right now I would be providing a psychiatric disorder as well as hypertension and fever and chills and headache and migraines. So the BP count, as usual, I'm just providing a random value of 100 and sugar as 100. So the prescription could be anything like either it could be something related to a general medical health care, exercise, or anything as such. So all this form related data will actually get encrypted in the background. So once I'm going to click on this create button, the block has been sent successfully. So now if I'm trying to log in through my through my email address, which initially had provided as Anand Hebali. So I will just log into my website. As you can see over here that I'm getting a generated email telling me to access your medical data record as a subject from the website. So this is my unique hash value. So I'll just copy this, and what patient in order for patient to view his blog, what he could do is he could either go to this login website, and into his module. he has to just enter out his credentials. So once he enters his credentials, he has to click on this get block data. So what is this website is it's more like a block explorer website through which he could access his block data by making use of these credentials. So he has to copy and paste this RSA key as well in order to decrypt the data. So once he copy pastes this particular credentials into his block data, he has to just click on submit, and you can see that he's getting the informations that the doctor has been that the doctor had initially given it to him in his module. So this is one way of encrypting the data and then sending the data's informations to the patient. So one more criteria or one more chance of having like, let's say if a particular patient dies, and if any one of his family members or uh, any one of them wants to claim his insurance money. So in that case, the email and password would be quite limited to the patient as such. So at the time of filling or at the time of registrations, he would be having this form known as references login. So what does this references mean is more like someone who is more close to him, like his wife or like his parents. He would give out their credentials in order to access his medical data record anytime. So this references login, let's say I forgot the password for anandabali@gmail.com. And what references login can do is he could just enter out the patient's name, which is I just this is the patient's name that that I had given during the registration time. And this is the reference name, which is his parents, and I'll be entering out the parents reference mail as such. So once these things actually it actually gets authenticated at the backend using MongoDB as such again. So once I submit on this submit over here, so you can see that enter the OTP which is sent to your mail. So again, the references mail should get an OTP indicating them that we have sent an email address, we have sent an OTP to your website. I mean to your Gmail account. So once this thing is done, yeah. So this is his the OTP, the newly generated OTP in order to access that particular patient's insurance claim. So once you copy paste this OTP over here, it's actually getting authenticated in the backend. So once I'm going to click on submit button, what I have to do is and over here you can see that once he actually claims or once the reference login is successful, he would be getting a mail telling him the credentials of the patient, which is Anand Hebbali, and this is the password for it. So once he gets this particular credentials into his Gmail, he could directly log into the system and finally claim for the insurance type that he is trying to access. And again, it works in a similar fashion as much as that of a doctor, where he can grant access to insurance A or insurance B or insurance C. So let's now try it out with insurance A. So I'm trying to give access to the insurance A to in order to access this particular patient's block data. So what insurance agencies will do is, what the doctor logins can now do is, in order to validate that that particular person has died due to some reason or is trying to claim an insurance, you could see that since I've added that particular patient to an insurance claim, the doctor has to just click on that insurance claim button and he has to create a block for him. So policy number could be anything. So it should actually authenticate with the backend in order to check if the policy number, the insurance type, and the cause of death, which could be accident or anything as such, and the claim type, either it could be full. And doctor validity and sign generally refers to the digital e-signature of the doctor, like just mentioning out his name. So once he tries to submit this, once the doctor actually tends to create a insurance claim for a particular patient, over here we could see that we could see in his console that the email has been sent to a particular website. So what the it actually sends the insurance record to the reference login in order to access his or her data. So what either it gets sent to the references logins mail ID, or it can also, the agencies can also look into these informations in order to provide the financial help. So as of now, I'll be providing the password and the username for the insurance agencies. Now, what they have to do is finally they have to enter the hash value as well as the RSA private key. As same as that of accessing a medical data record through a patient module. So once he clicks on this particular submit button, you could see that it's actually getting decrypted into the patient name, who has a policy number of 12345, and the type of claim that he's trying to do, and the cause and other things. So once the insurance agencies tend to verify this particular information from these provided credentials, he or she can either grant an access to claim their insurance, or they could either seek their financial help through these agencies. So that concludes our demonstration part. So coming back to the conclusion, so we have encapsulated with the latest and most the secure technologies over here. So we are not just providing the privacy part, we are also concluding it with the data protection, privacy, as well as security in it. So the future works can include, like, we could use the blockchain platforms like Ethereum, Solidity. Also, you could provide a cross platform type solutions in case if we tend to access it using a mobile phones, or we could create a scheduling systems for doctors and patients based on their availability in order to provide a prescription or for a general medical checkup. So also we could provide a dashboard in the website to know and view details regarding the schedule. And since we are using IPFS, which provides a decentralized storage systems over here, we could also replace it with the much more enhanced cloud services in our systems. So that's it from us.